Good morning, afternoon, or evening. How y'all doing today, guys? Welcome back to Mr. Morrow's Algebra II class. We had finished up yesterday right here. We have some discussion of whether or not we did C, so I'm just going to go ahead and do C, and then we'll just continue forward from there. Remember always, guys, that whenever we're adding or subtracting binomials or trinomials or polynomials in general, okay, when I have a negative here, I must distribute that negative first. So I have 5 minus 10i plus 7 plus 6i. Okay, now I just add like terms. 12 minus 4i. And boom, we're done. So we had a couple different answers here. Does that clean everything up here, my friends? Yes, sir. Can I simplify that further? Yes, actually I could. I could factor out a 4, giving me 4 and then 3 minus I, sir. Thank you, my man. We're good? Okay, now guys, let's talk about multiplying complex numbers. When multiplying complex numbers, treat I like a variable, okay? Now, we had already mentioned that yesterday, and I'll explain to you why I want you to treat it like a variable, not a radio. Remember that when we multiply the same base, you keep the base, which in this case is I, and add the exponents. And remember, please, that I squared is negative 1. Okay, this sounds good, Mr. Moore, but what does this mean? Well, let's say I have 2i times, again, 3i. If that was just 2x times 3x, wouldn't that just be 3x squared? But it's an I, so this time it's going to be 6i squared, right? What does I squared equal? So this really equals a negative 6. Does that make sense, my friends? So that's why I'm telling you, treat the I just like a normal variable. When the bases are being multiplied and they're the same base, you keep the base and add the exponents. Yes, sir. Thank you. I couldn't have said it better. You took the words right out of my mouth. What my boy said is, it is a variable, Mr. Morrow, except you know the value of that variable. That's exactly right. I know that it's 2i times 3i, so that's 6i squared. But I know the value of I. I squared is negative 1, so negative 1 times 6, negative 6. Thank you so much. So, everything that we learned before is the same, my brothers. Distributive property, FOIL, all that jazz is the same. The only thing we're changing up here is that there's an I. So, whoop-de-doo. 5i times 4 is 20i. 5i times negative 2i. Negative 10i squared. What is I squared, though? Negative 1. So this is 20i plus 10. Remember, please, to write it in standard form. So this is 10 plus 20i. Usually, guys, you can factor, but usually they do not ask you to factor. Excuse me, because that is your complex number. Done. For B, wait, I saw a face there. Are we good? Okay, thank you, sir. For B, again, distribute, FOIL, FOIL, FOIL. Negative 2 times 3 is? Negative 6. Negative 2 times negative I is? Positive 2i. Excellent. 6i times 3 is? Positive 18i. Beautiful. 6i times negative I. Negative 6i squared. But what does I squared equal? So this really becomes positive 6. So my total answer would be 20i. Very good. Because the 6 and the negative 6 canceled. Excellent. I told you this was easy, guys. It's just a lot of stuff, you know. I just didn't have time to do it all yesterday. But this is easy peasy. Now, when we're multiplying radicals, I need you to understand here that there's a little tiny difference, okay? If I just had straight up square root of 36, well, that doesn't make sense. Let's just say I had square root of 5 times square root of 4. That'd be the square root of 20, right? Because we can multiply the insides of the same radicals, right, guys? Does that make sense? Now, if we did that here, though, a negative times a negative, we'd cancel that out and make it a positive, correct? And that's wrong. Whenever you're working with square roots that have negative radicands, whenever you're working with imaginary units, complex numbers, okay, in radical form, please take out the I and then multiply. You with me? Take out the I and then multiply. In this case, it's beautifully easy. This is just 6I times 3I, which is 18I squared, which is negative 18. But let's say I told you something that wasn't so pretty. Let's say I told you negative 5 times, I don't know, negative 3, okay? Please do not make this mistake. Oh, that's the square root of 15. No, it is not. No, it is not. I'm not trying to be rude, but no. That is not what you do, boys. What you do is this. You take out the I, square root of 5, times the I, square root of 3. Now you've got I squared times the square root of 15. Guess what? That's negative square root of 15. Do you guys see the progression there? Please do not make this mistake. That is bad. Bad, bad, bad. Okay? Make sense? Super. Easy peasy. Okay, now, before I start doing this, what do you think I would suggest you do? Simplify, yes. Very good. So what does this simplify to, gentlemen? 3 plus 5I, thank you. Minus I square root of 5. Very good. You almost made a very common error. I'm glad you did that. He said I, and then he went and he caught himself. It's not I square root of negative 5. Once you take out the I, you got rid of that negative 1 in the square root. So now FOIL. 3 times 2 is? 3 times negative I square root of 5? That's exactly right. Good job. 5I times 2? Plus 10I. 5I times negative I square root of 5. Okay, it's negative 5I squared square root of 5, which I know some of you already simplified. You said that's I squared is a negative, Moro, so it's going to be 6 minus 3I square root of 5 plus 10I plus 5 square root of 5, because that negative 1 times a negative 5 gives me a positive. I don't have like terms here. Moro, what about the i's? You can't add 3I square root of 5 and 10I. They're not radicals. Remember, you can only add like radicals with the same radicands. Yes, sir. What about them? How? 3I and 5, they don't combine, my brother. Do you see what I'm saying? If you wanted to, you could do this. 6 plus 10I, factor out, factor out a square root of 5, and then have a negative 3I plus 5 left over if you wanted to get crazy. But I wouldn't do that. You can't add like terms here. There's no like terms to add. 6 doesn't add to anything. 10I, Moro. 10I and negative 3I square root of 5, you can't add those. Can you add 10 and square root of 5? So you can't add 10I and a 3I square root of 5. And then I have a square root of 5 here and a square root of 5 here, but I can't add 3i's and a positive 5. Does that make sense? Promise? Okay. Now, complex conjugates. Conjugates kind of messed you guys up. Okay? Real quick. If I have 2 over square root of 3, the conjugate here is straight up just the square root of 3. But if I have 2 times square root of 3 plus 1, guys, the conjugate, remember I told you, so a lot of you forgot this on the test. You just make that a negative. So it's square root of 3 minus 1, square root of 3 minus 1, and then you distribute. 2 square root of 3 minus 2 over. This part messed you up too. This is a difference of squares. It's the square, it's the first term squared minus the second term squared. So this is 2 square root of 3 minus 2 over 2. I can divide that 2 to everything, giving me square root of 3 minus 1. If you don't want to memorize that trick, do it the long way. Square root of 3 times square root of 3 is 3. Square root of 3 times negative 1 is negative square root of 3. 1 times square root of 3 is square root of 3. 1 times negative 1 is negative 1. These cancel. 3 minus 1 is still going to be 2. So that makes sense. You remember that, guys? Conjugate, I changed that middle sign. Same thing here, boys. Complex number complex conjugates are the same as regular conjugates, except for the fact that you're working with complex numbers. In order to find the complex conjugate of a given complex number, simply write the given complex number in standard form, which is a plus or minus bi, depending if it's plus or minus, and change the sign of the imaginary part. Make sure you write that in standard form, though, guys, okay? Please, standard form. So if I have a complex number 5 minus 3i, my complex conjugate would be 5 plus 3i. If my complex number is 2i plus 7, I first rewrite it, 7 plus 2i, standard form, then it becomes 7 minus 2i. Now, what happens when you multiply conjugates? Just like I showed you in the example before. When you multiply a complex number by its conjugate, or for that matter, when you multiply a radical that has a sum or a difference to its conjugate, same thing happens. You create a difference of squares and are left with the following. First term squared minus second term, not the I, just the B, second term squared. And I'll show you and prove to you why. I'll prove it right now. A times A is A squared. A times negative BI is negative ABI. BI times A is positive ABI. This is negative B squared I squared. Yes. So then this cancels. And actually, wait a second. It should be a plus. Yeah, it should be plus B squared. Sorry there, guys. Because I squared is negative. Yeah, that should be plus. Yes. Yes. Let me test it again with this one right here. Let's see. I got 8 times 8 is 64, plus 40i, minus 40i, minus 25i squared. Yeah, that becomes positive. So this is going to be 6. Yeah, okay. My bad. My mistake. I apologize. That was stupid. It is plus. So when you multiply complex conjugate times a complex number, it's the square root of the first plus the square root of not the square root, the first term squared plus b squared. Yes, sir.
Well, it will still be minus the equation because b squared will then be a minus, so then it changes it. Yeah. Like the equation is still minus.
I don't. Well, if it is minus if you include bi. Because look, this is right. So it's really plus b. Let me do it the long way, and then we'll verify, see if we get the correct shortcut. 8 times 8 again. That's not 8. Silly. 64. Plus 40i. Minus 40i. Minus 25i squared. So those cancel. So I got 64 plus 25, which equals 89. So first term squared, 64. Okay? So you could do it one of two ways. Actually, I see what you're saying, Jose. You could go minus second term squared. What's the second term squared? 25i squared. Doesn't this I squared make that a positive? So yes, I was right as well. I was right. It is negative. Yes. This, let's do it like this. Because this is really considered your B term. But yeah, let's make it like this. Your first term squared minus your second term, which is BI squared. Does that make sense? And it also works if you just go the A term plus just the real part of the imaginary squared. Or you could just do it out the long way. So this is the first term squared is 4 minus the second term squared is 16i squared. So that's going to equal 4 plus 16, which is 20. Or you do the long way. 2 times 2 is 4. Plus 8i minus 8i minus 16i squared. They cancel. That becomes positive, and it's 20. Either or, I don't care. Whatever makes your life easier. Whatever makes your life easier. Does that make sense, though? Yes, sir. You got a question, my brother? Okay, sorry. May I continue, my brothers? Okay, now, last thing. Remember that we cannot have a radical in the denominator, right? We have to rationalize. Well, when we have I in the denominator, isn't that a radical as well? It's a square root of negative 1, but it's still a radical, right? So we're going to have to actually do a conjugate. So whenever you have division, when you divide complex numbers, you must write both numerator and denominator in standard form, of course, and then rationalize the denominator by multiplying both the numerator and the denominator by its own complex conjugate. Since you can't since you can't have a radical in the denominator. Remember, if you have an I in the denominator, that's the square root of negative 1, so that's a radical. So let's rationalize. I got negative 4 plus I over 2 plus 3i. What's the complex conjugate here? 2 minus 3i. So let's do this. Negative 2 times 4 is negative 8. Negative 4 times negative 3i is? No, positive 12i. I times 2? No, 2i positive. I times negative 3i. Negative 3i squared, which becomes plus 3. So now this is negative 5 plus 14i. Does that make sense, gentlemen? Okay, yeah. Good catch, thank you. Let's go ahead and reverse that. So it's negative 5 plus 14i over square root of the first term squared minus second term squared. So this is going to be negative 5 plus 14i over 13. Go ahead, my man. You said or what? 4 plus 9, which is 13. Beautiful, son. Because that I squared is a negative. Yes, whatever makes you understand it and feel good about it, brother. Thank you, kid. May I continue, gentlemen? Okay, awesome. Let's do this. 4 plus 3i divided by 1 minus 3i. It's the standard form. What's my conjugate? 1 plus 3i. Okay, let's distribute. 4 times 1, 4 plus 12i plus 3i squared, which is minus 9. Okay, I could take that. That's negative 5 plus 15i over first term squared minus second term squared 9i squared, which is a negative 9, so that's positive 9. So that's negative 5 plus 15i over 10. I could take a 5 out of everything, so I got negative 1 plus 3i over 2. Does that make sense, boys? Talk to me, kid. You sure? Yes, sure, my brother. This last part is not factoring. Yeah, you got to simplify. Please. And thank you, sir. I wouldn't mark it completely wrong, but maybe take off a little bit. Now here, I have 5 plus 6i over 2i. I didn't want to not show you how to do this one. What's the conjugate of that? Just 2i, not negative. Just straight up 2i. Just like if I had 5 over square root of 3, you multiply by square root of 3 to top and bottom, right? Same thing. So this is going to be 10i plus 12i squared over 4i squared. So this is negative 12 plus 10i over negative 4, which I can take a 2 out of everything. Negative 6 plus 5i over negative 2. Come again, sir? If you wanted to go a little further, you could make this 3 minus 5i over 2. These two, I'd accept either one of those. Thank you, son. Good catch, brother. Does that make sense, boys? You promised me. Sir. Come again? What's 5 divided by a negative? It's negative, right? Because I went negative 6 divided by negative 2 is positive, but then 5i divided by negative 2 is negative 5i over 2. Thank you, sir. Because a positive divided by a negative is a negative. Thank you for your clarity, guys. Thank you, thank you, thank you. So right there's the answer. You got that, my man? Yes? No, thank you, sir, for your honesty. Okay, we did that. Okay, now, last part. This is the fun part. This is the fun part. If you look at the way many teachers and many books teach this, I would agree with you. I would just want to close my eyes and just go, no, 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 no. Because the way that some people teach this is crazy. Okay, I found an easy way to do this a long time ago. So if you follow my directions, these problems literally will take you about 5-10 seconds, tops. Let me explain. Evaluating the powers of I is very easy. If you remember, first of all, the following facts. I is the square root of negative 1. I squared is negative 1. I cubed is negative I. And I to the fourth is 1. So when you're looking at I to a certain power, wouldn't it be safe to say that every set of 4 i's comes out as a whole number 1? Is that safe to say? Then you got this already. Whenever you have to evaluate this power, simply divide the given exponent by 4. Why? Because every 4 i's comes out as a 1. You with me? And use your remainder as the new exponent of I and evaluate from there. What is this crazy man talking about? How many times does 4 go into 38 evenly? 9 times, right? That's 36. What's left over? So it's I squared, so you got negative 1. Not the 9, Papa. You just, okay, what you did here, thank you so much for saying that. 4 goes in 9 times evenly. So doesn't that mean, Papa, that I took out 9 sets of 1? Because I to the 4, every time I take out 4 i's, that's a value of 1, right? So I took 9 sets of 1. What's 1 to the 9th power is 1. Right? And then what was I left over with? 2. That is what I put there. So I squared negative 1. Does that make sense? How many times can 4 go into 98 evenly? 24 times. And what's left over? Yes. Shh. Negative 1. The 9 is nothing. Okay. Okay, guys. Guys. Relax, relax, relax. It's okay. That's why people ask. That's why I ask you to ask. Thank you. Okay. Every set of 4 i's equals 1, correct? You with me? How many set of 4 i's are in 38 i's? 9. So I have 2 i's left over, don't I? I took out 9 sets of I to the 4th. What's I to the 9th? It's just 1. Times my remainder of I squared, so that's negative 1. You with me, my man? You had the courage to ask. I want to make sure you have the courage to answer you correctly. Promise? No, 9 is not. No, remember. We're looking for sets of 4. Okay, look, guys. I'm going to do it the way they normally do it, which I hate, but I want you to understand this. We said 38. Okay. Okay, bro. How many sets of 4 can I pull out of here? Okay. I got 1 I to the 4th, and then another I to the 4th, and then another I to the 4th, and then another I to the 4th, another I to the 4th. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I have 2 i's left over. 1, 2, 3, 4, 5, 6, 7, 8, 9. What am I left over with? 1 i. What is I to the 4th? 1 times another I to the 4th, times another I to the 4th, times another one, times another one, times another one, times another one. 1, 2, 3, 4, 5, 6, 7, times another, times another. That equals 1 times my leftover of I squared. You want to do it like this? God bless you guys. I'm not going to do it like this. Every set of 4 comes out as 1. How many sets of 4 were in 38, my friends? 9 sets of I to the 4th. So what does that equal? 1. Are you with me here? Are you sure, my man? And then I have a leftover of 2, so it's I squared, which is negative 1. How many times does 4 go into 98? 2, that's an 8, that's 8, that's 4, that's 16. What's left over? I squared, so that's negative 1. How many times does 4 go into 101 evenly? 25 times. What's left over? 1 I. Done. What? Yes? Square root. I is the same thing as square root of negative 1. You could put I or negative square root of negative 1 because I know that they're both the same. I squared make it negative 1. How many times does 44 go into 43? 10 even times. And what's left over? I cubed, which is negative I. Easy, right? Told you this was a joke. It doesn't matter how large that I is. For example, I to the 11th. How many times does 4 go into 11 evenly? 2 times. What's left over? I cubed, which is negative I. Done. We're golden? Golden. Thank you very much. Hope you learned a lot and have a wonderful day.